Alright, let's get into some definitions just because calculus is pretty picky on wording and all of that kind of fun stuff. So it says the limit of a function is the y value of your function L that function approaches when the x value gets closer and closer and closer to some arbitrary point C from the left and the right side. So again, it has to be the same point on the left and the right side. So when we say that the limit of f of x as x approaches C is L, we write it like this. Again, I am going to be very, 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 very picky this year about that notation. I do not want to see limit as x approaches C of f of x is equal to L. This is incorrect and not allowed. I was like that last year for a reason. There is a very particular way to write limits. Alright, so applying this limit definition to our last example, I would have had the limit as x approaches 2 of f of x, which is the x squared minus 4 over x minus 2, should be equal to 4. Because each time I got closer and closer and closer to 4. Alright. Next one says use graph of the limit as x approaches 2 of g of x, where g is defined as this problem. So let's go graph this out. So I should get alright, all the way at 2, and then I can't equal 2, so I'm just going to leave a little gap there. And then it says it's going to be 0 at 2, so I should have a point here. Alright, using the definition of limit, I am going to ignore what I actually have at 2, and I am going to see what number I approach y value-wise from the left and the right. So, I am approaching this particular line from the left. Alright, from the left all the way across, it is approaching my y value of 1. From the right, I am also approaching my y value at 1. So my limit in this case, go back to pen. So my limit as x approaches 2 of g of x should be equal to 1, even though it's not 1 at 2, your limit. So as it gets closer and closer and closer to my x value of 2, my y values are continuing to be 1. It doesn't matter that at 2 it is 0.